First of all, very good morning. Thank you to everyone for joining on a Saturday morning. This is part of our ongoing webinar series. We try to do one every 2 months, and our intent is really to have one of our NCG members, one or more, showcase some interesting work that they've done in the digital place, whether it's a homegrown solution or it could be a vendor solution, and bring that to the for the benefit and awareness of other NCG members. So that's really the sort of the way we've structured this. We try to avoid vendors just coming and making a sales pitch unless that solution has been implemented within the NCG ecosystem, so that we know it's a live working solution. So we have a great lineup today. We have a couple of things. We have Dr. Khyati, who's going to talk about the Digital Health Foundation course at the Rajkot Cancer Society, one of our centers that are implementing the oncology EMR. And then obviously we have Dr. Santam and Dr. Indranil talk about the AI-based auto segmentation in radiology. But I thought I'll just very quickly catch you guys up on what has been happening at NCG KCDO broadly. So this is broadly the roadmap that we've been working on, and we've highlighted a few things in red only because I wanted to focus a little bit on those initiatives. So first, I think the oncology EMR, we continue to see a lot of progress. We now have 20 hospitals that are in different stages of implementation of the EMR. But the good news is that we do have 4 hospitals that have gone live. That includes the Mizoram State Cancer Institute, the Karnataka Cancer Therapy and Research Institute, which is at Hubli, the Mahatma Gandhi Cancer Hospital, that is at Miraj, and then the Kamla Nehru Memorial Hospital and Regional Cancer Center at Allahabad. So, first of all, thank you to all of those institutions for really making good progress on not just deciding to go with the EMR, but also driving all of the implementation processes and change management that was required. And we continue to see a good, healthy pipeline. And our expectation is that as more organizations go live, we'll also learn more about how to drive adoption, and then we can bring that to all of the institutions. Also, what has happened in the meantime is that the entire product journey with all of the vendors that we have implemented is largely complete now. So they pretty much have the full oncology functionality that we had envisioned when we started. Of course, this is an evolving space, so as we learn more, we'll continue to add. But by and large, when you see the product now, it is fairly ready from an oncology perspective. So that is number one. The other thing, the Digital Health Foundation course, I think Dr. Khyati will touch on anyway, so I won't spend time on that. And then Swapna will touch a little bit on the Digital Health Solutions Library. But I want to talk a little bit about the oncology AI ML, again, also the subject of today's discussion. There's a lot of talk, right, about AI, and I think we still struggle with a couple of things in India. One is just the availability of data, and if you don't have good data, a lot of the work on AI or the use cases, they kind of fall by the wayside. So we are still putting our early thoughts in terms of how do we build the right framework and bring the right technology partners together so that we can create an infrastructure where that data sharing can happen more freely with due regard to all of the regulatory privacy security considerations. And our intent is to really then expose that data to vendors who have interesting solutions, but will not mature unless they get a chance to work with real data. And so right now we are just at the early stage of looking at all of the use cases that are feasible from an oncology standpoint and have a good clinical impact. And we are running that through the lens of, is it scalable? Is there data that is readily available? And for the ones that we finally decide to shortlist, we will then go out and either look at whether an existing solution is already being deployed in the market. There are a few that may have been tested and are now ready to scale. Then that's one set of solutions we can bring to the NCG ecosystem. But there are many more that might just be in the early stage where lab testing is done or just in the prototype stage, where we will actually fund them. We'll actually fund the hospital to deploy that solution and learn from that. So again, there'll be a little bit of that matchmaking process where there'll be a bunch of use cases and solutions that are available, and then we'll have the NCG hospital sign up for the ones that they are particularly interested in. And then a lot of the process expertise, funding, and even the legal perspective, a lot of hospitals struggle with what happens to the IP and what happens to when the solution actually succeeds. So we are trying to put all of those things together so that the NCG hospitals can truly focus on really testing the use case and clinically validating that. And then two other quick things. We have spoken about synoptic reporting in the past. We are just in the final stages of releasing the tender so that we can take the solution that was developed at TMH initially, and now perhaps many other institutions use versions of synoptic reporting. But we are going to rebuild that in with a modern architecture such that we can offer that in a SaaS format, both for pathology and radiology, and in the with the intent of both streamlining the reporting and making it more comprehensive, but also making it very affordable to smaller institutions that may not be otherwise able to build that sort of a solution. And then the last thing I'll mention is we've now started working on the public patient education, because again we realize that there is no credible place in India as a one-stop to go for cancer content, which both applicable for the general population but also for cancer patients and caregivers. So we're going to do two sides of that. One is a public-facing app which will have a lot of awareness content and some basic information on NCG centers and services, some communities they can reach out to. But we are also going to develop a collaboration platform for NCG, because I think that is also something that is missing with now 300 plus centers or 350. We need a more structured way of communicating with each other than just Gmail and WhatsApp, right? And so we are still thinking through that, what would be all of the features, but that's also coming. So with that, let me just turn it over to Swapna before she then turns it over to the speakers.
Yeah, thank you. Thank you so much, Dr. Nikesh. So I will quickly just share my screen. So with respect to DHSL, as everyone knows, it's the Digital Health Solutions Library. And, we have spoken about this or mentioned this in the past, and there are a lot of posts and information that's being floated over various social media. But happy to now inform that the DHSL is live with 70 plus solutions, which are distributed across 5 categories, mainly clinical decision support systems, HMI, CMRs, remote patient monitoring and telemedicine, diagnostics and screening, and operations and quality management, right? So we just wanted to show you that in case you are looking for, any unique solutions for your unique problems or concern areas, if you log into the Quetta Center for Digital Oncology website, all you have to do is click on DHSL. That's when this page opens. You click on View DHSL Directory. And this is where the entire listing can be seen. So if you click on Filter By, you'll see the 5 categories. Okay, and say, for example, you're looking for a solution on remote patient monitoring. You will click on that. You can also select headquarters. Of course, if there are solutions which we know are based out of certain cities, then you can see it here. If you don't want to really select anything, you just leave it as is. And then you hit search. Now, if you see, there are around 12 records here listed on patient monitoring as well as telemedicine. So for example, say we'll go to DOSI. I click on it. And here I'll be able to see, some detailed information about DOSI. On the left-hand side, I'll see where this solution is based out of. I'll have contact details of the people who I can reach out to, their website. There's also information here about what DOSI really is, when it was established, how big is the organization, and a little more in detail about the particular solution that we are really talking about. And we've also listed references where the solution is currently being deployed, right? And what's the kind of engagement they've been having at these hospitals. So if you want to know more about this solution, you are interested in actually looking at the solution and deploying it for your organization, and also maybe you want to talk to these references to get a little more insight about how really it's used at the organization, you can reach out to the contact people over here. Their phone numbers and email IDs are provided. And yeah, so you are through. Of course, from KCDO, the website, you redirected to the DHSL page. If you go on the NCG India website, all you have to do is click on Healthcare Practitioners and you will see Digital Health Solutions Library here, which opens the same page. Yeah. So the idea here is really to let you guys know that, if you are interested in any solution and probably it's not listed here, or you need some help in kind of navigating the right solution for yourselves, then please feel free to reach out and we'll be more than happy to help you navigate. Yeah.
A couple of quick things. One is the one thing that we have tried to do differently is rather than just this becoming another raw directory of endless number of solutions, what we have done is we are only listing solutions that are implemented in the NCG ecosystem. So that way you have a couple of references to reach out to and really ask how the solution is doing. So that way, in some respects, it's a little bit of a qualified solution in that sense. However, we as NCG have not taken the path of actually assessing the solution. And so in some ways, that is really left to the hospital, but we are providing all the information that you need, which is why the number of solutions are at what they are, right? Today they are 79, maybe they'll become 100, but we don't expect to be like 1,000 solutions just for the sake of listing everything that's out there. So that's kind of one major difference. And like Swapna said, if you are aware of any vendors that you are using or that you don't see, please let us know. We'll continue to evaluate and expand them. And our intent is to really help you guys through this. So one other call for action is also that please inform your IT teams as well, because I'm assuming that many times they will be the users who may come here and then start looking for certain kinds of solutions. So if you can do that, that will be great. And if anyone needs to engage with us on a specific solution, then you should reach out or they can reach out to us and we'll be happy to help.
So can I ask one question?
Yeah, sure.
Yeah. So these are all for the oncology. These solutions
Yes,
are all
we have.
related to
That is one of
oncology.
the filters.
I'm saying telemedicine. So all telemedicine related to teleconsultation oncology only.
Yeah, not necessarily. So there are two parts to that. One set of solutions are solutions that are only for cancer, right? That they only address a cancer specific use case. The other set of solutions are solutions that are otherwise general but are applicable to oncology. So from a telemedicine standpoint, it is not that the solution has today been customized for oncology, but we feel even if it's in its current form, a cancer care center can also use it.
Okay, fine.
But we are on that point. I forgot to bring that up in the main slide, but we are working on right now defining the operating model for what a telemedicine solution for oncology should be. And so much like we did with the EMR vendors, once that is done, we will bring that to all these telemedicine vendors and ask them to incorporate that into their process. And part of what we are really trying to experiment with is an assisted teleconsult. That the feedback we've got is the technology is not the problem. There are probably hundreds of platforms now available, but the time that an oncologist has to spend to either go through the reports or sometimes the patient has not gotten the test done, that is where there is repeat calls or the doctor doesn't have the time and then they'll have to come back again. So we are experimenting with an operating model where we are putting a clinical person at the front end who will engage with the patient. This is not an oncologist. It could be a MBBS or even a BMS, BHMS resource, but has some clinical training that can go through all of the reports of the patient, arrange them in a chronological manner, and create a nice case summary, much like a resident would give you in a physical OPD. And only when all of that is checked, then set up the call with the oncologist. And our hope is that the oncologist has a very good experience, one with the technology, but more so with the information that they have to make a very quick decision, both in terms of a follow-up call and a new patient. And we are just we've started a pilot with with Tata Memorial. But the second one we are launching, we'll announce that next month, is with the state of Manipur, where they've converted 3 district hospitals. They've given us OPD space. So we actually had 3 nurses that we hired in each of those district hospitals. And we have trained them at TMH in terms of how to engage with the patient. And so now patients from Manipur, rather than having to come to TMH or any other center for that matter, can first come to these district hospitals and then we'll do a teleconsult today with TMH. Eventually, once the model is successful, then we'll roll it out across and then really decide whether they can be referred locally. Do they really need to come to TMH? Do they need to do some investigations and then come back? So that's what we are attempting to do.
Yeah. Can I ask a quick question?
Sure, Ajit.
Yeah. So I'm from a startup in diagnostic AI. We're in process in registering it. So there are 2 quick questions from benefit for others who might be interested. First is what kind of feedback mechanism is there? Like you are explaining about what is the need on the ground so that we can tune our product. We are early stage. And second is, since you are already deploying the stuff with say Manipur Hospital, wherever. So is there any formalization mechanism for the collaboration? These are the two quick points.
Yeah, so I'll quickly answer and then we can separately connect. What we'll do is, why don't you reach out to us? We'll have a separate call so that we can talk to you about the process that we follow from a very early stage startup, like you said. But the current project was structured as a research proposal. So we had a formal call for research proposals at the time. And that's how we initiated the partnership. Because again, we are a government institution, so we have to follow that process. But we can again cover that as well. So I'll just put our email address in the chat for easy reference, and then you can just write to us. We'll set up call separately.
Yeah, thanks.
Thank you, Dr. Nikesh. So now I'd like to bring us back to the DHFC. So we recently conducted a successful full day DHFC training session at the Rajkot Cancer Hospital. And now I would like to invite Dr. Khyati to actually share her experience and takeaways. Dr. Khyati, over to you.
Hi, good morning, everyone. I am Dr. Khyati Vasavada from Rajkot Cancer Society, and I'm a head and neck oncosurgeon and a medical director here. So recently, this hospital is there since almost 5 decades now, and then the hospital and the staff were using papers for everything. It's been an old practice to put everything on paper, and the main aim of the hospital and the management now is to make the healthcare system more efficient and sustainable. So for that, to improve patient care and to have a streamlined operation with the enhanced healthcare outcomes, we were a bit in the mode that we should digitize the whole system to paperless hospital where we can deliver the better patient care, we can save time of doctors. So how do we go about it? So initially, after discussion with Dr. Nikesh, what was the thing in my mind that we should be priming all of them with a foundation course, a digital health foundation course, which was done at Rajkot Cancer Society. It was a bit organized with NCG and Amrita Tech. That is taking a staff to the step where they know what is the importance of the digital process. And in turn, what it will help is that it will smoothen the process of digitization. So how we divided the whole thing into it, like the doctors took that training as an the course, the whole team of NCG, Vinisha and Krupa, they were with us for 2 days, and then we divided the whole thing into the parts that the doctors take their training, then the nursing staff, then the customer care and the coordinator staff. So how will they work to implement this system into the hospital for the better quality? Obviously, we need a digital health infrastructure which ensures a proper delivery of all these things. But what happens here is, see, when the hospital is using papers for each and every small thing since 40 years, so priming them about what we are going to do and what we are going to achieve with this digitization process. So this the foundation course has laid the important base for all the staff, which will probably make my and the other hospitals' IT staff who's involved in the process, which in turn will make their work easy. That how do we go about it, what benefit we are going to get, what patient benefit will achieve after implementation of this digital process. So obviously, as we are right now currently in the process of implementation of the software, the integration and the implementation and all these phases, we are currently doing that. So my experience with all these things says that a proper future proofing of this system, the digital system, will help in the smoother implementation, I would say. So Digital Health Foundation course is really a very good thing. It is really very beneficial for what you are going to do, as long as you prime all your staff, all your nursing staff, all the medical officers, everyone, for what are you going to achieve in the near future, what are you going to implement, what are you going to do. So for them, it is a bit easy to implement that. From our side, from the management side also, it is easy for us also to make them implement the same system in the patients. So I must thank National Cancer Grid, the Koita Digital Foundation, who helped us in financially, functionally, everywhere. They helped us in bringing in the software with Amrita Technologies, they are with us since almost, I think, 1.5 months now. And then they slowly and gradually, each and every department, they are trying to integrate, they are trying to implement, they are trying to learn everybody, like a radiation department or a surgical oncology department or a medical oncology. Each and every department, one by one, they are trying to teach them, they are trying to make them understand that what are they going to do, computer-based, totally digital hospital flow, totally digital hospital operations. So I think that's my experience on Digital Health Foundation course, and I actually insist everyone who is thinking towards digitizing the whole hospital, which actually is probably the best thing, and it will adapt the environment for a future technologies, for future advancements, which you actually want to in turn integrate it upon. So this is actually a good exercise to do, and see, honestly, that saves a lot of time. Me being trained in Amrita Hospital, Cochin, I had experienced that doing it paperless and doing it on paper, what difference it makes in terms of time, in terms of consumption of all your energy, everything. It saves a lot of time of doctors, it saves a lot of time of the staff. But obviously, as we know that the implementation thing takes little time and the little hurdles as well. So I think that is it about my experience. Thank you.
Thank you. Thank you so much for sharing that insight, Dr. Kathy. Yeah, I would also request Amit from Amrita if he could take like a minute to share, his insights into how the experience was post the training, of course, because, all the deployment, they are currently deploying the oncology AMR at Rajkot. So I really want to hear from Amit also on his experience.
Yeah, thank you, Swapna. I see Dr. Kathy also. Happy to hear from her. A lot of positive inputs. And good morning, Dr. Nikesh, everybody in NCG and everybody out there in the webinar. So in fact, I'm really very happy to share my experience as I had attended the introductory session of the DHFC course in Rajkot Cancer Society. So mainly we attended this course in RCS as our HMIS training was coordinated along with NCG for the DHFC as well as our HMIS. And personally, this course gave me a valuable opportunity to reinforce the evolving needs and expectations that we as vendors consistently aim to address. But while we are deeply engaged with industry standards and hospital workflows, this session helped reaffirm that our focus on interoperability, ease of use, clinical relevance aligns well with the hospital teams that genuinely they expect on the ground. So what really stood out to me is how DHFC is not just about digital tools. It's about building a shared language and understanding between hospitals and the technology providers. Right? That's something Dr. Kyari also touched upon. Right? So whether it is doctors, nurses, administrators, or even IT vendors like us, we're all part of the same ecosystem. And for EMR adoption to succeed, we need to move forward together. That's very important in the implementation. So, I mean, Dr. Kyari was touching upon the time that is being taken, the difficulty in implementation. So, she's very, very firmly put it across. So, the course lays a foundation in digital health concepts from the basics of EMRs to the importance of data standards like SNOMED CT, ICD, HL7, FHIR, etc. For vendors, these standards, like, for us, these standards are the backbone of how we design our systems. But for hospital users, understanding these frameworks, these terminologies means they can ask the right questions, okay, evaluate the system also better, and ensure they're working with us for a solution that is future ready and interoperable also, right? And the strength which I have seen is its alignment with the ABDM, Ayushman Bharat Digital Mission. As we move towards a more connected health network in India, it's vital for all stakeholders to understand terms like privacy, the importance of privacy, data security, the consent protocols. So this course reinforces these aspects very well, ensuring that the digitization happens responsibly. That's very important, right? We can digitize, but we also have to be responsible for whatever we are doing in terms of data security, patient privacy, etc. And from a
Correct.
vendor's point of view, EMR implementation is not just about deploying some software like, install Microsoft Office and then leave. That's not how an ERP implementation, or especially on the HMIS front. So it's more about the change management, right? And
Yeah.
most often the biggest barrier we see is a lack of awareness, or comfort with digital systems. There is an apprehension most of the time. So that's exactly where the DHFC touches upon, and that's where it helps very proactively. It prepares the hospital
Right.
teams to engage confidently with digital tools and to understand
Thank
why
you.
we are introducing certain features and how it ultimately benefits the patient care. So especially in oncology, I mean, Dr. Khyati would definitely agree with me, like where multidisciplinary collaboration is required, long-term treatment plans are there, and a lot of detailed documentations are very crucial. Now, so EMRs can play a transformative role, but that transformation can happen only when vendors and the hospital, the care team workers, everybody work as partners. So DHFC very clearly is helping to bridge that gap, or it's creating a bridge over there. So I truly believe
Thank you.
the important step towards building a mutual trust, digital readiness for our hospitals, empowers the staff with knowledge, and it also helps vendors like us to deliver solutions that are better aligned with the goals of individual hospitals and the whole industry at large. So I sincerely thank NCG and Koita Foundation for this visionary initiative, and encourage all hospital teams and vendor teams to take full advantage of the DHFC course. Because
Thank you.
the more we learn and align now, the smoother and more impactful our digital journey will be.
Thanks a lot, Dr. Khyati and Amit, for this. So I know that everybody is waiting for the next topic, but I quickly want to, mention that we have, if any hospitals are interested in running this course at their hospitals, please reach out to us. We have partnered with MedLearn, who will facilitate the course for you through their trainers for an in-person training program. So that is also possible. And of course, the course is available on the NCG Learning Portal for any of you who want to take up the course. The data is all, available, so you all can take up the training session yourselves, right? So now, without wasting any more time, I'm really delighted to welcome Dr. Santam and Dr. Indranil, both senior consultants in radiation oncology from Tata Memorial Hospital, Kolkata. Over to you, Dr. Santam.
Tata Medical Center.
Thank you, Swapna. I hope everybody can hear me. I'll just, Dr. Shantam will share the slides and we'll get started. Thank you to all of you for joining this. This is something that we are really excited about. As radiation oncologists who are, engaged in the treatment of cancer, segmentation or contouring is a very core part of our day-to-day routine. And for the last few years, we have been, working really hard to develop a solution that might help our colleagues across the country. So our solution. Are the slides visible? Yes.
Yeah.
Okay. So we'll get started. The solution that we want to show you is called DRAW. DRAW stands for Deep Learning-Based Radiotherapy Auto-Segmentation Workflow. And this has been developed at the Department of Radiation Oncology and Tata Medical Center, along with a very close cooperation with our colleagues at the Department of Computer Science in IIT Kharagpur. And it's funded by a grant that we generated from our departmental funds, and we are very proud of that as well. So what we're going to discuss today is we'll quickly introduce the team, we'll describe the goals of this project, and we'll demonstrate the project to you. You'll probably see a poll coming up on your screen. So if you can, quickly answer the poll for those who are radiation oncologists. Swapna has kindly set it up for you. We'll get a background idea regarding what your current situation is. So while this is going on, I'll quickly introduce the team. From the IIT side, we're very happy to have Professor Jayanto Mukhopadhyay joining us. And alongside him, two of his students, Sandeep Datta and Kaustav Ghosh. Sandeep was very instrumental in setting up this process, and Kaustav is helping us now. And from the Tata Medical Center team, it's my pleasure to introduce Dr. Rimpa Achari, my colleague, Dr. Sanjay Chakraborty, Dr. Shantam, who is going to demo. He's the lead of this project. Dr. Tapesh Bhattacharya, Dr. Moses Arun Singh, and last but not the least, two young people who are the imaging data scientists working at our department. And these are Mr. Shogoto Maiti and Mr. Ronajit Das. Next slide, Shantam. Now, the fundamental question we have to ask is that why do we need this solution at all? At the moment, there are approximately 700 linear accelerators in India, and over a year, it is probably estimated about 250 to 500,000 patients undergo radiotherapy that might require segmentation or contouring. We also know that automatic segmentation methods can cut down time by 60 to 80%. There are several publications that address this. And this can therefore address the shortage of trained workforce spread out all over the country. But it also improves something else. It improves consistency, because we know that when two individuals contour, they tend to be a little different. But we know that commercial solutions are already present. They're coming into the market. They're getting available to everybody. Then why do we need this solution developed in a hospital, an academic solution? The first point is that no matter how the prices drop, a commercial solution will always be a little relatively expensive and may be out of reach of several colleagues, especially working in smaller centers. But there are two other very important points. The first thing that is, when you buy a solution from a company, they may not make a commitment to adapt to changing guidelines or institutional practices very fast. And we know that practices change, guidelines change all the time. Suddenly you're faced with new guidelines, and then you're back to manual contouring. So can we develop a solution that addresses this issue? The second is, what we know is that we all contour a little differently. Some people will join two structures and make a single structure. Some people will keep two structures separate. We all have our little, ways of doing things, just like surgeons, operating. Now, we need a solution that will learn from your contours and give you back an automatic segmentation. It doesn't have to be a rigid system based on a certain principle. Now, DRAW is designed by us, we are expert end users, and intends to solve these problems and to scale with demand so that we can roll it out to innumerable centers across the country. So I'm now going to pass the baton on to my colleague, Shantam, and he's going to demonstrate to you what this solution is.
Yeah, so to introduce DRAW, as we know, DRAW is supposed to be a solution which sits in the middle of your segmentation pathway. So we have designed this solution in a manner that it can integrate with your existing workspace and your existing work practices very nicely. This is a brief overview of how the system works, and then we will see the real demonstration. So imaging obtained from your imager comes in a central data store, as it does. And we do not interrupt this flow of data going to your TPS. We simply take that data, pass it through our client, which does something called as de-identification. And for those who are not aware of this, de-identification is removal of personal health information from the DICOM data, such that it can be safely sent out over the cloud. After which the server sends it out to a dedicated GPU instance. So this is very interesting that we do not actually segment directly on the server where it is being sent. We create a new GPU instance, segment, send the structure set back, and the client machine then re-identifies the structure set and sends it back to the TPS. So by the time your physicist is ready to import the CT from your PACS or your data store, your structure set is already present along with the CT scan. Now we'll see how the demonstration works in this video.
When we install the DRAW client system into your system, we provide you with a 5-step configuration which allows your client to communicate with our server. The first step is to set up the data store path. Now this data store path is the path where your DICOM data is saved, and we want the RT structure also to be saved at the same place. We allow you to start When we install the draw client system into your system, we provide you with a 5-step configuration which allows your client to communicate with our server. The first step is to set up the data store path. Now this data store path is the path where your DICOM data is saved, and we want the RT structure also to be saved at the same place. We allow you to start pulling the data at a defined date and time. The next step comes with configuration of the API settings, which allows your client to communicate with our server. The bearer token section over here is auto generated by the server, and the refresh token allows these bearer tokens to be automatically refreshed at 30 days interval. The most unique feature of this system is that you can set up automatic segmentation templates. Now these templates are basically collections of structures which our auto segmentation models will segment for you. You can search for each structure name. So for example, here we are searching for the breast. You can view the various model statistics, delineation guidelines, etc. on our website. Now once you select these structures, they start getting added to the template. So for example, here we have selected 3 structures, then the 4th structure, and you can choose to select the structure that you want for your template. So for example, if you do not want the thyroid in your template, you don't choose it. Once you click create template, it automatically creates a template for you with the following structures chosen. And this can be seen in the admin section, where we can see that the example templates has not been associated with a rule set. Now, in order for the system to run appropriately, we need to configure some rules which tell which automatic segmentation template is to be associated with which type of DICOM file. And the way we do it is that we associated these templates with the DICOM file based upon the metadata tags. So for example, here we are choosing protocol name as the metadata tag, and it will read the value called your choice in the metadata tag if it is available. If so, it will associate this template and it will send this template and the DICOM to the remote server. Now if it does not, it will send it to an unprocessed queue from which there can be manually handled. You can later on review the template that you have decided so that you can understand what structures were there. Now this is a real-time overview of how fast the processing takes place. Although copied DICOM should be refreshed first, but the browser refresh did not happen first. So here we have set up 5 series, of which de-identification took place, and 7 series were actually sent across to the server. The server allows you to view the statistics or processing of the cases also. So if you go to the admin login section, you would be able to see your case list. In this case, we have logged in as the admin, and as you can see that each case is associated with a unique GPU server, and therefore once this GPU server has finished processing, it will automatically delete the file. The client system keeps on polling the remote server to get the latest status. So here you can see some of the statuses change from pipeline activated to copy. And let's go back to the original figure where we had explained how this thing works. So pipeline activation is when the remote server tells the GPU machine to activate the auto segmentation pipeline after it has finished copying the DICOM dataset. And you can see that these status keep on changing. So segmenting means that the GPU server has started the auto segmentation process. In this way, once the segmentations have been completed, these segmentations are retrieved back by the server and then sent to the client. The client then re-identifies the dataset and sends it back to the DICOM storage where it originally came. And you can see that the original time for processing started at 4:17 and all the series have completed processing by 4:49 PM. This is the power of parallel processing that our system allows. In this demonstration, we will see how the NNUNet models perform as far as the segmentation is concerned. We are giving a visual overview, as you can see the model quantitative metrics on our website. In addition, when you select a model, quantitative metrics on our website. In addition, when you select a model, quantitative metrics lie on our website. In addition, when you select a model, quantitative metrics like the diet similarity index, the median house draft distance, and the over contouring under contouring distance metrics are also available. Here the mouse pointer is showing the eyes and the optic structure.
Just a minute, I will go to YouTube. I think there is some issue with the video playing here.
Similarity index, the median house draft distance, and the over contouring under contouring distance metrics are also available. Here the mouse pointer is showing pituitary, optic nerve, brainstem, and all of these pituitary, optic nerve, brainstem, and all of these are head neck OAR models which are derived from the head neck model. So you can see that the performance is quite reasonable, and we can see as the contour goes down, we have segmented the DAR structure, which is generally a difficult structure for auto segmentation models to segment. Our larynx segmentation may be different from what you are segmenting, and this is one of the advantages that we have with this system, is that we can accommodate your contouring practices, and in addition we can also train models which are adapting to new guidelines as they emerge. Now in this sagittal section we can show the levels of the spinal cord and the brainstem, and this is as per the guidelines which are followed at our institute. In the next case we will see that the performance of the model in a more thinner patient. Now this patient we have selected particularly because the body mass index is quite low, and this has been a problem when we evaluated segmentation solutions generated from the West, where models were trained on more obese patients. And we can see that because our training data set was representative of the Indian population, we got a reasonable model performance even for this patient. In fact, all the structures have been drawn. Now let's go on to the breast model. Now this is a patient of breast cancer, and we can see that the brachial plexus are being segmented on both the sides, the SCF volume, the internal mammary nodal volume. The breast volumes on both the sides are drawn as per the latest ESTRO guidelines. You can see that the contours match the breast contours quite well, and this is because of the training data set that we have used. Liver, heart, lung, spinal cord, esophagus, everything is drawn. In addition, we have also drawn the left anterior descending artery, and therefore this model promotes the concept of drawing of cardiac substructures. Here we are showing the results obtained from the prostate model, and the prostate model was actually the first model that we trained. And you can see the bowel bag, the nodal CTV, the bladder, and as we come down, the anorectum and the femoral heads as well as the prostate gland are segmented. The penile bulb has also been segmented. Our prostate model performance is quite good for most of the organs, except for the superior aspect of the bowel bag, where there is some variability which is reflected in the modern performance. This is the segmentation of gynae cases. Now this model was quite interesting because we only did this training with a very few number of cases. And you can see that the performance in terms of segmentation of the para-aortic nodal region, kidneys, abdominal organ, etc. are quite reasonable. Here we are highlighting the possibility of nodal substructure solutions, and here external, internal iliac, obturator nodal volumes have been separately drawn. Now as we are showing in this, again this shows how flexible our model is. So we can accommodate different types of guidelines and different types of requirements for your model segmentation needs. The next model that we will show you is new. This is something that we have trained over the last week, and this is MRI substructure segmentation, and we demonstrate using this method that our model is capable of doing multimodality segmentation. These are substructures drawn in the brain like the orbitofrontal region, the eye, retina, cornea, the brainstem, amygdala, hippocampus, and the supratentorial brain as well as the superior and the inferior part of the cerebellum. As we can see that these complex structures often take more than 30 to 40 minutes for our fellows to draw as per the ESPT and Atlas, and this segmentation can be performed within 3 minutes using our draw system. One of the last segments that we wanted to demonstrate, and this would be quick, is planning structures. Now, our physics planning structure drawing is often quite complex in order to meet the OAR constraints for breast, and all of these substructures that you are seeing have been drawn by the draw system. So if your physics planning system utilizes a very formalized way of segmentation of structures, we can help with generating model for generating your substructures.
So sorry for the glitches. Now going back. So what is unique about Draw is that we are quite flexible and customizable, as you saw. You can not only create your own rules, you can create your own protocols, and this can be easily integrated in the workflow. We do both target volumes and OARs, and we are expanding our portfolio to include GTVs also. Our system follows a unique model mart system. So in the future, when there are hundreds of models available on the system, you would be able to select models based upon validation statistics or contouring guidelines to suit your need. We can add new models very fast. If we have a curated data set, then new model training is possible within 1 week. We implement parallel processing, so there is no additional time lag. It is extremely cost effective and eco-friendly. So because we are using GPU resources only on demand, and we have a very user-friendly interface for non-technical users, so your technicians or radiographers can actually handle the system independently. Most importantly, we are vendor independent, so we are not locked into a particular TPS system. We take security very seriously, and therefore one of the fundamental things that we do is PHI de-identification. That is, all personal health identifying information is removed from the DICOM dataset. We do authentication at the client and the server level using password-based systems. There is a bearer token-based authentication in all the communication between the client and the server. Tokens are automatically refreshed as they expire. And there is an encrypted access provided to the server. The data is not retained in the server or the GPU, and it is completely deleted from the systems. So this is our clinical use. We have actually used the system since January 2024. The current server system is something that we have developed recently. And more than 2,000 series have been segmented till 8th of April. We have now models trained for prostate, gynecological cancer, head neck cancer, breast, brain tumors, thoracic neoplasms, and we estimate around 1,600 person hours have been saved using the draw system. And now I hand over the thing to Dr. Malik, who will take us through the next part of the presentation, which is the validation study plan.
Thank you, Shantam. You know, AI solutions look great when they are being used in a single center, but they often are not as great, as you know, when it is, thrown out to the public. Now, every AI solution needs a validation study. And before we can say that our solution is really good, we need to perform a validation study across several centers. And we would be delighted if you can join us in this, in this process. Now, the goal of the validation study is very simple and very specific. Validation needs to be done at the level of the end user. It's not a set of experts sitting somewhere who can validate whether it's good or bad. You have to validate it because you will use it for your patients. Secondly, the validation has to be limited effort. It should not take hours of your time. So we want to look at 3 aspects: the implementation, the quantitative evaluation, and a qualitative evaluation. The first part is, can we install the program called the client in your department? Can it access your data store? Can it pull patients as soon as images are coming in? Can it de-identify them, send it to the server, get the auto segmentation done, pull it back, re-identify it, and put it back into that same folder effectively? We feel that we can do this implementation part within a couple of weeks. We can test this implementation in a couple of weeks. And then over the next few weeks or months or years, we will perform the quantitative and qualitative evaluation. Next slide. Now, what we want you to do is not draw things entirely on your own. We want you to start with the auto-segmentation solution and edit it or change it based on what you do. And we will then de-identify your final plan or approved contours and check using standard quantitative metrics, which are outlined on the right, to see whether, how good our segmentation is performing at your level. And we target, a BDS score of 0.7, but I think that this will vary with structures. Some structures, we would completely expect it to be about 0.95, etc. And some structures which are smaller, like in all auto-segmentation methods, will not perform as well. Next slide. But numbers cannot tell the entire story. We also want your comments. We want you to really critique how our segmentation model is performing based on what you have used for auto-segmentation. And on the right is a table where we want you to tell us what you feel. This is not a drop-down selection. We want you to tell us if it's really bad or whether it's felt that the upper cuts and lower cuts are a problem. And that will help us improve our solutions considerably. But what is most important is that if you find that our practice, our auto-segmentation and your segmentation practice is considerably different, you draw structures a little differently, you combine some structures we don't, etc., etc. What we offer you is that you give us a few patients with your segmentations drawn, and we will create a model for you. And then we will test, then you will test whether this new model is working in your setting. This, I believe, sets us completely apart from any other solution available, whether open source or whether commercial. Next. As you can see, there are many other use cases for a segmentation library. It's not just about your clinical use. An auto-segmentation library can be very valuable for research purposes in clinical trials, doing radiomic research, for quality assurance in multi-center clinical studies, and as Dr. Shantam pointed out, for planning structure creations to help your physics colleagues do the stuff faster, just like this is doing the job faster for you. So thank you very much for your patient hearing. We are very happy to take any questions that you have. While the questions are coming in, there's a QR code on the screen that leads to a Google form. If you are interested in helping us validate this solution, please let us know through the Google form, and we will be in touch with you. This will also be used to, see how much interest there is and whether we can, show this interest to potential funders, because we want this validation study to be funded by different agencies. Happy to take any questions from any of you.
How authentic are your templates and how was it validated? That's a very important question. So we actually follow a multi-step validation method. As far as the templates are concerned, these are text, basically text files. So the templates themselves do not have any model information. The models are actually in the server. The validation actually is done on a two-step process. There is an integrated validation process which is built inside the model training pathway. And after that, we have a holdout sample of about 15 to 20% patients where we actually quantitate all the metrics. And these metrics are all published on our website. So whenever we release a model, the model metrics, the model guidelines, how these structures were obtained will be always available to you for your review. Then there is a question by Dr. Agarwal on CTV retrospective segmentation. Not really sure what this question is.
I think JP sir, thank you for coming to this meeting. We really appreciate it. So there are two types of CTVs. One is an elective CTV, and that is a rather relatively easy problem to solve. So for many of our target organ sites, we have elective CTVs as a part of the auto segmentation process. Now, for the primary and nodal CTVs of gross organs, now that is a much more complex solution, and we are starting to work on that. We are starting to see whether we can have organ-specific models where the GTV can be contoured and a margin given, and anatomical edits can take place. To our knowledge, there aren't too many commercial solutions for this. But we are working hard, and if enough centers join and we can do a project together, we will be very happy to do it.
Excellent. That's what's the whole thought of process on that question. Thanks, Santam and Renil. Second thing, what I want to understand, if it's permitted.
Yes, sir.
Yes, sir. Go ahead.
Okay. You will have many patterns of recurrences.
Yes.
Yes.
Have you seen to integrate with your auto segmentation?
No, sir.
Not yet, sir. Not yet.
Not yet.
So
sir.
I
But
think,
it can be done.
I think, Santam, let's work also parallelly on that
Sure,
to learn on many things, that will be another big dimension for our work.
We
Thank
will, of
you,
course,
dear.
need good quality training data sets, sir.
We are the game. I think Sarvani is also there on the system. I am the game. Only the problem is, I think Simon also wrote it regarding.
So we'll clarify that. We'll clarify that. Sir.
Please.
Before that,
That is-
let me take Dr. Sujana Priya's question on how many cases are used to train the prostate model or the pelvis model. For the pelvis model, we actually trained with 20 cases. And the prostate model, we trained with 60. So our largest training data set so far has been about 120 patients, which we used for training the head neck model. But there is no real limitation on the upper lumbar. The more the merrier. But for a easy model, actually a very small number we realized is quite good. So coming back to Dr. Simon's question as well as Dr. Agarwal's question, where is the cloud server located? So the cloud server is currently located in Bangalore. It is being hosted by a company called DigitalOcean, which has servers in Bangalore. But it is important to understand that our solution is not dependent on DigitalOcean. And we can actually migrate to a cloud server at any point of time. So there is no restriction in terms of being sort of restricted by a single server provider, so as to speak. Any issues with draw talking or connecting to the machine's vendor OS? So we have actually been testing this system for about 3-4 weeks now, using different computer systems. And we haven't had any situations where the API client did not return a response. We had 1 or 2 instances where the GPU machine did not start up, but that was easily rectified by a simple manual triggering of the process. And we have an inbuilt notification system which actually informs the administrative workers that this segmentation has failed to implement. Dr. Simon, have I answered your questions?
Yeah, am I audible?
Yes, Dr. Simon.
Yeah. So I think the issue has always been with institutions is where will the data go, and
yes,
our
so
internal
one very
problem,
important point is that we are actually not retaining any data.
Yeah.
We actually delete the data immediately after the client sends us a response that we have received the segmentation. So we don't retain any data on the server. The data that is retained is completely at your end. It's on the local machine. We only receive the de-identified data, and that is also deleted as soon as the segmentation is done.
Yeah, I understand, but trying to get the authorities to understand is the
Yes.
challenge.
Yes.
And other thing is always is when we try to bring in something, the vendor OS, there are a lot of issues. That is the biggest challenge. Getting
No.
that to talk.
Which vendor OS are we talking about? You mean the TPS OS?
No, whenever it goes to the planning system. Once you have
There is
done-
no problem,
Yeah,
sir.
okay,
We
okay,
have
that
actually
is-
tested this out.
Yeah,
We have
okay.
tested out
Okay.
that because this is a DICOM RT structure set, if your
Okay.
OS, if your vendor system is capable of reading an RT structure set, there is no problem. It doesn't involve your TPS at all. We are completely segregated
Okay.
from your TPS. So we don't install any software on your TPS whatsoever.
Yeah, no, that I understand. But when these come back, anyway, we can have a discussion outside
Yes,
this
certainly.
forum. Yeah.
So there is a related question from Dr. Benny about on-prem server system. So currently we are not, we do have an on-prem system at Tata Medical Center, but we are not going to be in a position to support on-prem server systems at different hospitals. Assessment form, of course, we'll share, madam. Can you share some numbers on index of segment?
One
Yes,
minute,
of course.
Santam.
Yes,
Santam,
madam.
can I just ask another thing?
Yeah,
Will
madam.
it be possible for you to share a kind of protocol for this entire thing? Because as Dr. JP was saying, we would be happy to validate, but then we would require a formal protocol for us to submit to EC and share data.
Of
So
course,
if you
madam.
would,
That is
if
the
you could
plan.
share a
Means
protocol,
the
yeah.
validation study, we will be, of course, coming up with a full protocol. And that is
Yeah.
one of the reasons why we sort of approaching NCG to get funding.
Yeah,
for
okay,
this.
okay, fine. Thank you, thank you.
Yes. And regarding Anushri's question, can you share some numbers on the segmentation? Yes. Actually, all the segmentation accuracy metrics are shared on the website. So once the model gets validated, we share the numbers on the website. So currently the website is hosted on a different domain, but because we are migrating. Yes. What was the question?
Dr. JP, you have to mute yourself.
Oh, okay. So regarding the question on the numbers, they will always be available on the website. And our client system actually will allow you to see these numbers when you select the structure. So this is very interesting that our client is quite likely going to show you maybe 3 or 4 available bladder models. And you can choose which bladder model you want based upon what is your requirement for accuracy, what is the requirement for your guidelines, and so on. Are there checksum verification? Of course. There is checksum verification for the received RT structure and there is checksum verification for the DICOM structure. So effectively what happens is there is checksum validation at both the ends. Next comes to how satisfactory are target volume segmentation. Target volume segmentations for prostate, I would leave to Dr. Malik to answer. Dr. Indranil?
Yes, I think that what we are very happy with the prostate segmentation. Our team rarely have to spend more than a couple of minutes making small adjustments and smoothening, etc., etc. So because it in prostate cancer, you know, the CTV is the entire prostate. So in fact the entire thing comes ready, and all we basically do is we smoothen the structures, we draw the PTV, we edit the upper border, the first few, the superior slices of the bowel bag, which is a bit off usually. And most of the time we are good to go. There will be small adjustments required, especially in patients who have, you know, TURP and things like that, where the anatomy is a little different. But other than that, it's a really, really useful model. Yeah.
Yeah, coming to breast, actually, again for breast, our breast model actually predicts the whole breast as well as the chest wall. SCF and IMN target volumes are also predicted. In fact, we actually predict the tumor bed also for breast cancer, which is actually a very variable model. And to our surprise, we did not expect it. The model actually is able to do a decent performance in, I would say, probably 2/3 of the cases that I see, which is quite good because even trainee radiation oncologists often don't perform that well. Coming to Dr. Pramod's question, he wanted to know whether auto segmentation will be done on RT planning CT only or in MRI or PET CT also. It depends. For example, we do have an MRI model for brain. So if you need an MRI segmentation to be done, we would be very happy to train a model for that, assuming that there is good quality data for it. So that I think answers Dr. Gaurav Jaiswal's question also. With regards to delineating head neck OARs, how many successful segmentation outcomes have come without major corrections? Okay, so we really haven't had a proper formal evaluation in our hospital because we actually have integrated it in our workflow. Dr. Indranil, do you have any idea how many are requiring major corrections in the organs at risk?
Small structures require corrections. The larger structures require much less correction. You know, sometimes when, you know, as you mentioned, in really thin patients, you have to make some edits. But, you know, head and neck segmentation takes a long time. So even the OAR segmentation, a lot of time is saved. we rarely have a situation where we have to completely delete a structure and draw it again. Yeah, except maybe the cochlea. The cochlea needs some editing, but otherwise it is all good to go.
So coming to Dr. Girish's question, what is the concordance rate with auto segmentation versus segmentation with radon? So as I mentioned, the validation statistics report the dice similarity score, the house drop distance, the under contouring and over contouring metrics. Now these metrics are quantitative metrics, so it is by concordance. Most commonly we use dice as the index. So for dice, there is a wide variation. For very small organs, as Dr. Malik mentioned, because these are susceptible to volume effects, the dice score will not be that great. But for larger organs, for example, breast, for example, liver, for example, pancreas, spleen, we get very good dice similarity scores. And as the model quality, as the training data set quality improves, the concordance improves. So this is very interesting that when we train with a better quality data set, we will get better quality results. I would leave the cost question to be discussed. Dr. Indrajit, finally somebody has asked this question.
Yes, Gitu, thank you for bringing this up. Look, what is the cost of doing validation? The cost of doing validation is in getting some manpower you will monitor these sites to help them get onboarded, to install the clients, etc., etc. And it's in the inference, so the cloud server costs, etc. Right? So we are, looking for funders to fund this project so that a lot of centers can benefit from it. Once the validation is done, if it is successful, if these centers want to use our project for clinical purposes outside of study, that's a point we haven't come to yet. But what we can absolutely, guarantee is that the cost of using this will be minuscule. It will be nothing that compares to any other solution provider. And we are not trying to make any profit out of this at all. So we are very confident that it will be something that people can afford. It's not free of cost, but the cost will be very normal. Yeah.
So
if there's a funder who's happy to sponsor this for centers for their first year or whatever it is, then it will be free of cost if there's funding involved. And believe me, there is no other auto segmentation solution that is employed nationwide. So if India can be the first country which employs where a central body or a funding body like NCG or ICMR or whatever funds it, then it will be an example for many other places. And we have interested people from Nepal, we've interested people from Bangladesh. There are people who know that we are doing this and have approached us.
Okay, thank you, Dr. Indrajit. Thank you.
So Sanjeev, which software have you tried and found the accuracy to be not good?
Sir, we have Varian Eclipse based auto segmentation license, and for the head and neck, 14% data we shared, but accuracy is not good.
Yeah. No, so I think that please, if you can, please try out our solution. We will be very happy to hear what you feel about this. Yeah.
Yes. Okay, sir.
Yes,
Thank
and
you.
Dr. Sanjeev, it is also important to understand that our solution is actually a deep learning based solution. Variance solution is actually an Atlas based auto segmentation solution, if I am not mistaken.
Okay, sir. Okay, sir.
Dr. Simon, do we expect any future problems from machine vendors who have their own solutions? I think most of the machine vendors have to accept that people will buy solutions from outside unless they bring down the costs. And we would love to, beat them at their game. Anushri, link of the website, yes, we will share, absolutely.
And then there is, you have mentioned the models can be rerun with our own image set structures to localize model, but I do not see it in the Django admin panel. Did I miss it? Okay, that's a good question, Jagadishan. The thing is that the model training does not go through the Django admin panel. The model training needs some manual work even now. We are hoping to integrate it at one point of time with the server so that the model training also becomes something that a person can do through a point and click interface, but currently it is not there. But it is not a very onerous process. If you have a curated data set, as I mentioned, it takes probably a week to get the model training done. Any variation in auto segmentation with different slice thickness, this is exactly what we would want to see. Because in our hospital, what happens is, because we work on a very rigid protocol, our CT scans are taken with very rigid slice thicknesses. And as a result, what happens is that we really don't know what will happen if I put this model for a different slice thickness case. That said, we have actually tested out this on randomly selected patients' data, which we have downloaded from the internet. Now, those were not RT planning CT scans. And we did not find that it was that bad. Let me put it this way. Does this have, or in the process of CDSC or FDA approvals? Okay. I'm not really sure whether we will ever go for an FDA approval or not, because that is something far in the future. CDSC approval, we will probably try for if we have sufficient interest in the solution, and that probably we can do as a part of the validation exercise.
Yeah, I'd like to add something here. We are not trying to provide an end-to-end solution at all. Yeah, we are trying to provide a first draft of a contour. It's a contouring assistant. It is not to be trusted, never to be trusted as a full-fledged end-to-end. You can, without looking at the contours, you send it for planning situation, because we don't believe as doctors that we are that replaceable yet. Yeah, there are, so just like, you know, my trainee will come to me with the first draft contour, and it is my responsibility to check it and approve it. This is what this software does. Okay, it gives you the first draft. You have to look at everything. You will have to approve it yourself. It's your responsibility. So not sure whether, you know, this, what kind of approval process CDSCO, etc. has for this. We will look into that. Have we approached Arroy? No, I don't think Arroy is the right body to approach in terms of funding for this, for example, because Arroy is not a funding body for for trials.
Not just funding, but what about the validation part? I mean,
yeah, so
will it...
the audience, Gitu, you here are Arroy members. So so what we will do is, once we have you know, sufficient interest, we will approach Arroy to share this information. And yes.
Yeah. A larger body appreciating it will, you know, reach more wider audience.
Yes, certainly.
So I think there are no further questions in the chat box.
Yeah, but we also have your poll results, Dr. Indranil, if you want to like go through that.
Yeah. Did you have the last question shared? Yeah, I took a photo of this. Yeah, so a lot of people feel that this will be very useful. And I'm surprised that a lot of people say that their 30 to 50% of their time is in contouring, which shows that this is, you know, labor intensive, and they about 80% feel that there will be a lot of benefit. So I think we are looking at an important aspect, and we will be very happy to have feedback on actual users of our solution.
Dr. Indranil, have you taken a screenshot of this?
I have taken of the poll, yes.
Okay, fine. So then I won't take it. Okay, there is one more chat message. Whether Atlas-based knowledge also can integrate with manual contouring as an additional measure. See, Atlas-based auto segmentation is a fundamentally different approach to auto segmentation as compared to deep learning method. But the training data set which you supply to Atlas-based knowledge will be useful for this model also. I think that is what I can answer. Does that answer your question, Dr. Pooja?
Dr. Santam, I was thinking, let's say manual contour is submitted and there is some structure which unintentionally got integrated as a manual contouring, and Atlas-based knowledge identify it as an error. That's what I wanted. So Atlas acts as a second reviewer or a critic on that.
So,
just to check
I understand what you are coming at, but the thing is that when the auto segmentation solution will send you the structure, it will send you the structure based upon the template that you are sending. So it won't create new structures for you. Am I making sense?
Can I take that question, Pooja? So I think you're asking that if you have already drawn something.
Yeah, and something by error, something happened, which we usually want our peer to check, like two-step verification, whether the AI, Atlas-based AI itself can verify it as a additional measure, and I don't have to depend upon any peer review.
No. This is not a replacement for peer review by any means. This is not a replacement for peer review. So this is pre-peer review contours.
Yeah.
Okay, thank you.
But you can actually see whether whether your contours are vastly different from what we are sending. That is one thing that is going to be useful. Validation comes from end user alone, or the software takes insight while creating structures. Okay. The thing is that the software does not have something called as a ground truth to actually generate the validation metrics when it is doing the segmentation. We don't have a competing model with which it can compare the results. So the validation has to come from the end user. It cannot come directly from the software.
If there are no further questions, I would like to thank KCDO, Nikesh, Swapna for allowing us to come here and present our solution. And please convey.
Dr. Inanil, there is another question on how satisfactory the OAR and target volume segmentations are in post-op cases in head neck cancer.
OAR and target volume segmentation post-operative cases. Yeah, okay.
For head neck cancer.
Yeah, so very good question. So we don't have target volumes in post-op cases. We basically have the OARs. And the OARs do quite okay. Yeah, so if you have a mandibulectomy, it is not going to confuse, it'll draw the bone that is there. In terms of, we are in the future, we are going to work on models that contour the flap. We are going to work on models that look at the CTVs of the ipsilateral neck, which are operated. Those solutions do not yet exist, but they should not take a very long time. Once we send something for modeling from our data set, as Dr. Shantam pointed out, it's just about a week's work. And so all of these will come up very fast. So we'll get to check it if you participate in the validation process.
Indranil, can I make just one or two?
Yes, absolutely.
So actually, it's really a learning for me to listen from the medical community. But what I want to also impress upon here, actually, this is a research problem also. So don't take it as a single closed form solution, and whatever performance you are getting, you will just be working on that. So there is a research going on. There is a backup team. So we are trying to improve the performance of this segmentation. That is one advantage we have in this process, that we have, like the Atlas-based integration of Atlas-based information. Definitely, I could see that there are potential research avenues which can improve this model, and there are many other things which we can apply. So just to impress upon this point, that this model is just not a solution which has been off-the-shelf solution. It is developed by our team also, and we have also contributed to various factors, and we are doing that also to improve this model's performance. So that's it.
There are two further questions. One is regarding whether we can approach the IT department of Government of India for funding. If there is a funding avenue, we would be happy to explore it. And what is the cost to organization? I believe we have already answered it. It depends on the kind of funding that we have available for the validation study.
Okay, great.
Okay, great. Thank you.
Closing remarks. So first of all, this is phenomenal work, right? So Dr. Indranil, Dr. Shantam, and the entire team, please take our congratulations and best wishes. I think there are very few solutions that we come across from a AI perspective that have actually really been tested, right, and been refined. And I would put this in that category. They're probably in single digits, right, in India. So I think from that perspective, I'm very excited about what you guys have done, and as is evidenced obviously by also the number of questions and the engagement on the webinar. So thank you also to all the participants who have been very actively listening and participating. I think from a funding standpoint, we'll figure out as far as NCG is concerned, because this fits very squarely within our AI/ML strategy, right? That we want to take solutions like these that are in some respects early stage, some clinical validation is done, and then support hospitals who actually want to implement this in their setup. So we'll come back to you with a process of how to apply for that funding, and also figure out if there's a formal plan just for this solution to be spread across the ecosystem, because that is really our intent, is that a lot of these digital solutions may evolve as an idea that a doctor had or a group of doctors have, and they tinker around that to a certain point where it now seems like there's a lot of potential, and then our job is to take that and percolate that within NCG. And whether they're successful or not doesn't matter, right? But the ones that look promising are the ones that we do want to support. So we'll come back on the funding side as well. And similar to this, if those of you that are on the call, if you have other solutions that you might have developed, even if they're not as advanced as this one is, please write to us. We would love to look at them and see if we can again engage specifically on that front. But yeah, I just wanted to close out by once again thanking both the presenters and the participants. This webinar is also recorded, so for those of you who may have missed it, we will send a link, or those of you who may not have been able to attend, your colleagues, other folks, we'll send you the link on the NCG India website. In even our past webinars are all available there. It'll take a few days just to edit it and remove some of the white noise, etc. But once it's uploaded, we'll send everyone the link. So with that, thank you once again, and have a good weekend.